Hey guys, this is Miss Moore. So I'm sorry I'm kind of late on the video about joints, but I'm just going to quickly go over joints for you because I didn't get a chance to talk about it in class because I totally forgot about it. Okay, so joints, what do they do? So a joint is two bones that meet together. All right, so that's basically what a joint is, which makes sense. So joints are going to hold your bones together by ligaments and also give you mobility. So if we didn't have joints, then we would just not be able to move. So we need joints. There's two ways of classifying them, the structure of them and how they function. And we're going to talk about that in a few minutes. Well, actually, in a few seconds, like now. So functional. So here's an example of how we classify them based on how they function. So we have something called synarthroses, and these are joints that are going to be immovable, meaning you cannot move them. An example would be like the sutures of the skull, the bones between your head. We can't move those. They're immovable. They need to be. You don't need to move them. The next kind of functional joints are amphiarthroses, and these kind of have movement. So these are going to be like where your backbones meet. All right, we need to be able to move those a little, but not too much because we could slip our discs. And then diarthroses are totally movable. I put bruh here, like bro. They're totally movable, bruh. Meaning like our ball and socket joints of our hips or our shoulders or our arm, kind of like where the hinge joint is, where our elbow is, where our knee is. They're totally movable. If they were synarthroses, we couldn't move them. So these are the three ways we classify them. There's questions on your review that apply these three definitions right here. Structural. So these are the structures that they could have. They can be fibrous, meaning that the joints are connected by fibrous tissue, meaning probably we can't move them. So the sutures in the skull are going to be connected by fibrous tissue. And that's because, again, we don't want them to move. So they're going to have fibrous tissue between them. The second kind is cartilaginous. So these are going to be connected by cartilage. This is going to be like the intervertebral disc of our back or the piece of cartilage between our hip that we saw in the lab. It's called the pubic symphysis. The third one are synovial joints. So most of the joints in our body are going to be classified as being synovial joints. So kind of like our elbows or our knees or our hips. Those are all going to be synovial joints. They're going to have cartilage. I put how cartilage, but it's supposed to say have cartilage. They're going to have that synovial membrane with that fluid in that cavity that makes the joints have cushioning. They're also going to be joined by ligaments to add some kind of durability to our joints. So most of them are going to lie right here, synovial joints. So our hip is an example of something called a ball and socket joint, which most of you already knew. The hip is going to be a diarthroses, meaning that, again, we talked about this earlier, it's totally movable, bruh. Okay, so a hip is totally movable and it's synovial. So it's going to have that membrane, that cartilage, that synovial fluid, all of that. Sorry, my dog's making like a crap ton of noise right now. Logan, shh. All right. The skull is going to be our synarthroses. So it's not movable at all, okay? And it's going to be connected, again, like I said, by fibrous connective tissue, which we saw here. The pubic symphysis, or again, our back, is going to be an amphiarthroses, meaning that it's kind of movable. We've heard about people before that are ambidextrous or however you say it. All right, so I always think of that term, if you know what I'm saying there. And it's also going to be cartilaginous. So the pubic symphysis is going to have that fibrocartilage connective tissue as well as the cartilage in your back. So they are slightly movable. We don't want them to be fully movable, but we don't want them to be immovable. Okay, so this is from your notes, right straight off the notes that I gave you. So here's our synovial joint. So we are just talking about synovial joints now. We're not talking about the cartilaginous or the fibrous joints. We are focusing in on synovial joints at this particular time here. So these are subtypes of them that we could have. And you probably learned this in 7th grade, but I'm just going to fly on through them one more time for you. So the first type of synovial joint is called a plane joint. And they just let bones glide beside each other. So there's no rotation. There's not a whole lot of movement, but there needs to be just some kind of movement there. So this is going to be like the carpal joints of our wrists. So remember all those different bones we learned in our wrists about, like silly lemurs try peanuts that they can't handle? That's what I'm talking about here. So all of those scaphoid, lunate, hamate, capitate, those are all going to be plain joints. So they're going to be able just to slip by each other and glide against each other, but no kind of drastic movement goes on there. So that's what it means by intercarpal joints. The next type is a hinge joint. This is just like a door hinge. So this is going to be like your elbow or your knee or your ankle. They're going to move just like a hinge. They're going to move in one plane. They're not going to be able to make a full rotation because they don't need to. So that's a hinge joint, and that's going to be pretty self-explanatory there. So elbow, ankle, knee, bam, you're done. The third one is my favorite. It's called a pivot joint. So I always think about, if you play basketball, how you use your pivot foot. I always think about that. So it's going to be a rotating action along some kind of axis. And the example I always use is the joint between the atlas bone, so that first C1 bone, and the dens of the axis. So when you turn your head like you're saying no, that's an example of a pivot joint. So it's going to rotate just like that. And that's going to be a pivot joint. So think like when you're playing basketball and you turn your head, it's kind of like you're pivoting. So a pivot joint. And I won't use any example other than that for pivot joint there. Okay, condyloid joint. This is probably the most misunderstood joint of all that you'll learn. But an example is going to be kind of like your knuckle area. So where your metacarpals meet your fingers. So they're going to need a little bit more movement than the plane joint, so the intercarpal joints. So they're going to be a condyloid joint. Logan, shh. Okay, so they're going to be a condyloid joint. So it's going to be kind of like an egg shape, fits into some kind of cavity. So I think of like whenever you balance an egg on a spoon. So it can't rotate, but it's going to, again, have that little more movement as you see here in this picture right here. Okay, a saddle joint. Some of you think I'm crazy because I told y'all this last week, but this is going to be the same movement as a condyloid, only it just makes a different movement. And the only one that I could find was the joint in your thumb. So I always think of like, I always move my thumb and I pretend like it's riding on a saddle, like back and forth. And so your thumb is going to be a saddle joint. It's kind of like it's riding a horse, as you see here. Okay. The last one is my favorite. It's most well known. It's called the ball and socket joint. It's literally a ball, so like the head of the femur, that fits into the acetabulum of the hip. So that's called a ball and socket joint. Another example of that is going to be your shoulder. Okay. So again, all these are synovial joints. So that's all I have for you. I know that was short. I know that was simple. It shouldn't be any issue. I think you should do fine on the test. I'll see you tomorrow.